All right, let's look at some CYUs for our linearization. So f of x is a function where I'm given this point, so I know I've got the point 2, -6. The slope is given by this equation, so that tells me that at my point 2, -6, then my f prime function, so my f prime of 2 is going to be 10/36. 8 is going to be approximately 10/36 times 1.8 minus 2, that's -0.2 minus 6. All right, here's my g prime of x. Use the tangent line at x equals pi/2 to approximate g of 1.5. Well, at x equals pi/2, g of pi/2 is going to be 3 sine of pi/2. Sine of pi/2 is 1. So 3 plus 1 is 4. So my tangent line will be y minus 4 equals my slope. Oh, haven't found the slope yet. So g prime of x is derivative of sine is cosine. Derivative of 1 is 0. So my slope at, not of x, my slope at pi/2, 3 cosine pi/2 is 0. So y minus 4 equals 0. So that tells me that I have a horizontal tangent at y equals 4. So at g of 1.5, I don't even have an approximation. I'm going to say, I do have an approximation because I know that my value at pi/2 was 4. At 1.5, it's still going to be approximately 4, but I don't have to do any further calculations. So now it says use my calculator to find g of 1.5, so let's do that. Oops, here we go. Come back to my calculator page. Let me clear everything out. So I'm in radians, that's good. 3 times sine of 1.5. Let's close the parenthesis. And then add 1. I get 3.992. So how far off was my approximation from the true value? Well, I can say that my difference of my approximate value, so 4 minus g of 1.5 is approximately, so let's come back here and do 4 minus my answer, 0.0075, but really that doesn't tell me much. So I really want to think about what percent I'm off. So I think that, or no, I don't think, percent error is going to be the actual minus the approximate divided by the actual, and I'm going to take the absolute value of that. So absolute value, in this case I don't need the absolute value because it is already positive, but I'll think about it anyway. Divided by the actual, and then times 100 to make a percent. So coming back here, I'm going to take this value, I'm going to divide by my actual. Ooh, I need parentheses around that so that I divide by the whole thing. All right, so put in my parentheses, close out my parentheses, multiply by 100, and my percent error. So that actually, even though this number seemed small, I'm actually, oh, this is my percent. So it is very small. My percent error is about 0.188%. So not far off at all.